Good evening, everyone. Thanks for joining. Let's wait for 5 more minutes for others to join. Thank you. Okay, let's start the session. So, good evening, everyone. Um, for those who join new, I will just give a brief introduction about me. This is Saravanan, PhD scholar and Prime Minister Research Fellow of Department of Civil Engineering, NIT Tiruchirappalli. So, I am a PMR scholar. So, as a part of PMR of deliverables, I am taking this course, problem solving session on the course Air Pollution and Control in NPTEL. So, this is my third course. Earlier, I have done for Integrated Solid Waste Management and also for Plastic Waste Management. And this time, I have taken for Air Pollution and Control. So, this is a 12-week course. So we are in the ninth week of the problem solving session. So you all know for the first 8 weeks we have discussed about what is air pollution, what are the air pollutant and its impact on the environment, ecosystem, to the human health, to the materials as well as to all the other animals and birds, everything we have discussed in the first 2 weeks. Then we have discussed about the source of air pollutant and its dispersion criteria. So how it got dispersed and what are the meteorological parameters like wind, temperature, humidity, how it's getting affected, the dispersion of the pollutants. So then we have discussed about how the dispersion is making the pollutant to sink in other places. So there is a source, the pollution is getting emitted, and there is a sink where the pollution is getting deposited. So that is called that mechanism we have discussed with the different models. One is Gaussian flow model, and we have discussed some of the problems related to that. Then we have discussed the emission inventories. So inventories in the sense how to measure the pollutants. So how to take the questionnaires, how to calculate the pollution based on from the source or from the point of sink, how to measure. This is the emission inventories we have discussed. Then in the upcoming weeks, we have discussed about indoor air pollutants. So indoor air pollutants and their impact. As a myth, we know like outdoor air pollution is much lower than the indoor air pollution. So we are spending a lot of time, more than 90% inside the home or indoors. So that pollution we have discussed and their control measures we have discussed. Then in the last week, we have discussed about so last week, sorry for the last week. So last week we have taken the course postponed session on Friday. Hope you have attended and the videos you can see in the SWAM portal. So last week we have discussed about the air pollution and their global and regional impacts like acid rain, climate change, global warming, ozone layer depletion, ozone layer depleting substances, how to control that and all we have discussed in the last week. So this week onwards we are going towards air pollution control strategies or air pollution control. Yeah. Uh, So I have compiled the PDF and I have uploaded again. I think you can see the PM. I mean, I will tell you how to see that also in the website. So inside the SWAYAM portal, in the course after the 9th, 10th week, you can see a PMR problem solving session. Click the link. You will be redirected to a Google Sheet. There you can find all my videos, all my lecture materials, all the problem solving PPTs, everything you can see there. So there is a compiled PPT PDF there. So I will also upload it's a weekly compiled PDF. Also, I can upload you a single PDF also, okay, at the end. So this 9 weeks PDF is already available. You can use for revising for final exams. Okay, yeah, got it. So this week we are going towards air pollution control devices. So this week we are going to discuss about particulate matter control devices and organic matter control devices. Okay, so let's move on to the lecture. So this 2 hour session will be go like first 1 hour we are going to discuss the same lecture material what Sarah has discussed in the videos, and the second 1 hour we are going to discuss about the old assignment problems. Okay, yeah. So how to discuss this air pollution control devices? I will just share the. Hope the screen is visible to you now. Yeah. How to control the air pollution? Why it's called air pollution control, not air pollution treatment? Because water, it's a part of environmental engineering. In water, wastewater, everything we will discuss water treatment, wastewater treatment. But why air pollution is not the treatment control? Because what are the pollutant we are discussing about like carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide? This all are part of air. So whenever a compound it's a part of something that we will always try to control. It will not be removed from the system. Once it is removed from the system, then it is called treatment. Once when the level is increased and we are trying to decrease the level, then it is called control. That is, we know air contains 72% nitrogen, 21% oxygen, and remaining as trace gases. So that trace gases contain CO2, CO, N2O, SO2, everything is there, and N2 is already there, it's 72%. So if something is getting increased that above the limit reference level, then we are trying to reduce the level. Then it is called air pollution control. We are controlling to the base level. If something is present in excess of this already existing component, then it need to be removed from the system, like any ozone or any volatile organic compound or refrigerant, what we discussed in the last week. That are all not non-existing air components that need to be removed. That are all called treatment. But whenever you are talking about particulate matter, CO2, N2O, these are all need to be reduced. So it's called air pollution control. You got it. So that's why this term is very important, air pollution control. Okay. So there is a main strategy called self-cleansing mechanism. So this was about the pollution control. So if whenever there is this is what I have discussed. Whenever there is a limit the damage to the environment caused by the discharge of harmful substances, then that need to be properly controlled. Whenever it's having any impact to the human health or to the uh, ecosystem, then that need to be controlled. That's called the pollution control. So pollution control need to have different steps or different uh, methods we can do. One is emission control from the automobiles that we can do. Uh, One second, I will reduce the thickness. Yeah, emission control we can do, or electrostatic precipitators to remove from the industries, or sanitary landfills we can do, sedimentation tank recycling. These are all pollution control techniques only. See, there are why it is required. Pollution control is required to frame number of policies and regulatory related decisions can be taken based on this pollution control strategies only. So the law mandates not to release into the environment, not to allow the escape into the environment, to contain and to recycle. If it is created, that need to be controlled within the premises of the industry or within the premises of wherever we are emitting that. So these three are major regulatory measures. So we should make the industry or any source need to be the emission need to be within the contained zone. So not to release, not to allow to escape into the environment, to contain and to recycle. So these are the major point you have to think about while thinking about the pollution control. So that there comes the natural self-cleansing mechanism. So whenever you know, right, there is a river. So if there is a river, yeah. So if there is a river and water is flowing in it, a industry is discharging some effluent into the river. Then after some point of time, you can see the river will be again clean. So why it's happening? Because of the dispersion, dilution, or some yeah, dispersion, dilution, adhesion. This type of mechanisms are happening in the flowing water that makes the pollutants concentration to a reduced level. That is called a self-cleaning mechanism. Naturally, it's happening because of the flow of the river. The same thing will happen with the air also. Because air is flowing, it's also a fluid. So it's moving because of dilution, because of absorption or gravitational settling. So there are the properties you can say it will get disposed or it may get settled due to gravity or it may get absorbed by some of the water or liquid. It may be absorbed onto some of the solids or rain out. Because of rain it will be settled down. So these are the five principal mechanism based on which the pollutant in the atmosphere may get reduced naturally. That's called a natural self-cleansing property of the air. Okay, so first one is dispersion. So see, all know like dispersion of pollutant is by wind because whenever there is a high wind, that will get that's a turbulent nature. We have discussed in the modeling also, right? So there is a stable condition, there is unstable condition. Unstable down condition is due to turbulence of wind. So whenever there is a high flow of wind, that will dilute all the concentration. If there is an industry emitting a pollutant, then if there is a proper wind, then it will be emitted, disposed easily. Then no, we can't find anywhere the high concentration of pollutant. So, but it does not remove the pollutant. That's the major thing. It will only dispose. It will not remove the pollutant. Then second point is gravity settling. So gravity settling will happen by natural mechanism at larger particles only because that's based on the yes. The light class filter. Oh, video. Video footage. I'm so sorry. 1 minute. There is a technical issue here. A minute, please. Yeah, I'm so sorry for that. I will continue the session. So we are discussing about the natural self-cleansing property of the air. So there are five mechanisms. First is dispersion. So whenever a pollutant is getting disposed, due to the turbulence of the wind, it is getting dispersed, but it is not removed from the system. Only the concentration is getting reduced. Initially, it was 5 milligram per meter cube of gas, that air, then it was mixed with the 10 meter cube of air, so it was 5 milligram per 10 meter cube of air, so it's only getting decreased, the concentration is getting decreased but not removed from the system. Same gravity settling will happen whenever there is a particle size of a larger dia, that will are denser particles that will easily settle due to gravity, you know, right? Some of the disk and all, if you take and see, there may be some particles deposited on the disk or on the floor, that is due to gravity. That's called a gravity settling. It will effectively work when particle size is greater than 20 micrometer in size. So even 20 micron particles are considered as larger particles, and they will get settled easily. Then absorption will happen as there are two principles we have discussed earlier: absorption and adsorption. Absorption will happen whenever a particle is mixed with a liquid. Then adsorption will happen whenever a particle is getting absorbed on the surface of a solid. That's called adsorption. So absorption will happen with rain or mist, a droplet of rain that may collect the dust particle in the air, and it will get settled. That's called absorption. So that takes place below the ground level, a cloud level. So cloud, there may be water droplet particles, because of the moisture. The particles will mix with the liquid, and it will be settled down with the raindrops. So that does not help in removing the particle less than smaller than the size of 1 micrometer in size. Okay. Then rain out. Rain out will happen. You see here. So this will happen involving precipitation above the cloud level. That is below cloud level. That is due to the particle. I mean, what we say, the mist or the raindrop particles. This will happen above the ground cloud level, where submicron particle present in the atmosphere in the cloud serves as a condensation nuclei. So around which the drop of water may form and fall out as rain droplets. So the particle will be surrounded by the water particles due to it's called a condensation nuclei by attraction, electrostatic attraction. Then it will get deposited as a raindrop. Finally, adsorption, same like absorption. Adsorption will happen on the surface of a solid. So it kept attracted generally electrostatically by the surface, because of charge maybe adsorption may happen, and either by gravitational settling or by inertial impact it will get settled down. Okay, so and how to natural cleansing strategy and their control devices. So all the devices what we are using nowadays for the control of air, we have learned from the nature. So naturally there are mechanisms that we are adapting in mechanical devices. That's what the principle behind. So most of the control devices are based on the principle of self-cleaning capacity. See, gravitational settlers are based on settling chambers are based on gravitational settling. Spray towers are based on absorption principle. Wet scrubbers, these are all the techniques we are going to see, but principle is adopted from the nature. So use of activated carbon, silica gel, these are all adsorption. That's again the adsorption principle happening in the nature. You got it? So these are all the principle we are using adopted from the nature. So first, why we need to do this air pollution control? What's the objective? Prevention of nuisance, because there should not be high concentration of pollutant in the atmosphere. Prevention of physical damage to the property. Elimination of health hazards, human health hazards. Then recovery of valuable waste products. Because whatever the particulate matter we are emitting, that may have some value. Whatever the organic matter we are emitting into the atmosphere, that may have some value. Then minimization of economic losses. So as I mentioned, lots of tourism damage, visibility, and material damage to the what we say, like historically important areas, that will cause economic loss, like rubber. Even all the vehicle tires are getting affected due to air pollutant, that also we have seen, right? So that are all economic loss to the country. Then improvement of product quality, these are all important objectives of air pollution control. Then what is air pollution control? As a definition, air is polluted when it contains a certain substance in a concentration high enough and for duration of long enough to cause the harm and undesired effects. So whenever this is again based on two things: one is concentration, one is time. So something which may be present for a minimum time, that may cause a severe damage, like ozone, like smog, pan particles. These are all staying in the atmosphere for a small time, but it will create a huge issue. But some particle may cannot cause a effect with lower may cause higher impact when they stay for the stay for long term in the atmosphere. So it's based on the concentration. It's also based on the time that may cause harmful effect to the human or any ecosystem. Then it need to be treated. That's called air pollution control. Then atmosphere is suspected pollution from or two things. As we know, like there are two sources. One is natural source, another one is human activity. So air pollution control is a technique to reduce or eliminate the emission of harmful substances before releasing to the atmosphere. This control is the strategy we need to adopt inside the industry or any source with before emitting into the atmosphere. If it get emitted into the atmosphere, we can't do anything. Got it? So these are the two main principle to reduce before emission, to control within the premises. So these are the two important principle we have to follow. Only pollution caused by human activities such as industry and transportation is subjected to mitigation and control, because whatever causing by nature, that can be self-cleansed by nature itself. So anthropogenic activity or anthropogenic sources need to be controlled. So what are the pollutants we have to target to control? So primary focus is on criteria pollutant. Like there are 6 criteria pollutant which are prescribed in IS code also. I mean, National Ambient Air Quality Standards, NAQ standards. So that also prescribed 6 criteria pollutant. First is particulate matter, both PM 2.5 and PM 10.10. That is based on the size, aerodynamic particle diameter. Okay, then carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, lead. These are the 6 criteria pollutant having proper standard, need to be within the standards. Why they are called criteria pollutant? Because whenever there is a this pollutant having a small quantity itself causing huge damage to the people or health effects. So since 20th century, end of the 20th century, hazardous effect of trace amount of many other pollutant called air toxins. These are all main compounds. After 20th century, we could able to see other than this 6, lots of air toxins are getting emitted into the atmosphere, like organic chemicals. So now we are discussing, we have a code for VOCs, volatile organic compounds, carbon, hydrogen, and other atoms that may form the organic chemicals. Specific emission regulators have been implemented for this pollution also. So how to control? As I mentioned again, these 4 are viable to this, like reduction at the source, reduction of pollution discharge at the source, dilution of source discharge, dispersion of source location. So these 4 are important. Like how to do this? Reduction at the source is once it is not getting generated, then no need to emit, right? So if you are having a good technology, like I am having a vehicle that is very old and that will emit lot of pollution to the atmosphere. So that is one. Another one is e-vehicle that is not having any emission. So I am reducing at the source itself by buying a electrical vehicle. So that is reduction at the source. Then reduction of pollution discharge at the source by control equipment. If I am having only the diesel vehicle or a petrol vehicle or a fuel vehicle, so for that I'm having a proper control system at the exhaust that may prevent the release of toxins into the atmosphere. That is called reduction at the pollution discharge itself. Then dilution of the source discharge using tall stacks, like industries, nuclear power plant, or any industries you can see a large stacks are there. That also we have designed in the first 3 weeks. So that why we are emitting at the larger height, because wind is blowing at a turbulent rate at that height. That will help to disperse the pollutant without affecting the ground level uh, atmosphere. That's why dilution at the source discharge itself. It should not be diluted at somewhere else. At the source itself, it need to be diluted. And dispersion of source location through the allocation of land usage. We have to properly plan the industrial area. That's why everywhere we can find SIPCOTs. That is the industrial sector or ecologically sensitive zone that need to be properly planned. That should be no industry there. So dispersion of source location is very important. This 4 need to be carried out before controlling, before thinking about air pollution control. So what are the devices or the methods we can use? By changing the emission can be reduced by changing to cleaner fuels and processes. That is from the transportation or any industrial sector. Fuel are the reason for emissions. So cleaner fuels, that's what we will call as green chemistry. Green chemistry, this concepts and all will based on reducing the waste or emission at the source itself. Because we are using now those who are from is environmental engineering background, they will know For a simple COD test in water, chemical oxygen demand, we have using lots of chemicals to that. So for open reflex, how much chemical we will use? For closed reflex, how much time and chemicals we will use? So this process is getting changed. Nowadays sensors are there. So sensors will not have any chemicals requirement. So that's called cleaner production, or cleaner green chemistry kind of concepts. So if we are also shifting the industry's fuel concept like this to cleaner fuels, then there won't be any emission. That need to be taken care first. Then if can't change, then the emission control at the source need to be addressed, like collected and trapped by appropriate air cleansing devices. The devices for the control of particulate matters for the stationary source. There are two sources. One is stationary source, one is moving source. Moving source are vehicles, car, whatever the exhaust we are emitting, that is called moving source. Stationary source are industries, landfills. So these are all called as stationary source or area source. So particulate matter, how to control particulate matter from the stationary source? We can use settling chambers, inertial separators, cyclones, scrubbers, electrostatic precipitator, fabric filter. So all are for particulate matters, PM control, because PM is having most health effects. So that's the first criteria pollutant. We all know. So PM10 and 2.5 can be controlled or captured by this techniques, five, six techniques at the source itself. These are all industrial scale. You can see one by one. So as I mentioned, stationary source, we can use this. Moving source, we can use this five technologies like exhaust gas recirculation, air injection system, catalytic converter. These are all the devices attached to the bike or car at the engine itself to reduce the pollutant. Positive crankcase ventilation valve, evaporative control system. These are all we are going to see. Okay. And area source like agriculture or dump site. This is all how to control. So dust and particulate control, maintaining the soil cover, wind barrier that will contain the pollutant within the area itself. Then crop residue burning control. So major pollution in the Delhi, as I told you, know, like it's due to burning of crop residues. So that need to be controlled by composting the residue. Why we need to burn a residue? It's a biomass. So we can get compost out of it by proper composting or anaerobic digestion if there is a proper moisture content. Then production of biochar we can do. We can think about pyrolysis. Pyrolysis will produce biochar. Okay, that is a controlled environment without oxygen at high temperature, but it is a energy intensive, but we can get a product out of it. Then mechanical devices we can use like happy seeder, the straw management unit. Like there are lots of inventions now coming out to reduce the crop residues or making value added product from the crop residues. So we need to think about the control of pollutant at the areas of like agriculture. Then forest fire, that is also controlled as a considered as an area source. How to control forest fire? That will emit lots of particulate matter. So firefighting reservoirs need to be there. Spraying of fire retardants, forest fire monitoring towers need to be there, like this type of watchdogs. And from a stationary source, as I mentioned, six equipments we are going to see. Variety of physical, nothing is chemical here. Everything is physical process. Because particulate matter, there is no chemical reaction. Nothing will happen with the particulate matter. We have to settle or we have to trap the particulate matter by size separation only. So air, there will be some particles. So air may pass through smaller holes. So we have to trap the particulate matter. That's the only physical method we can take out. If it is an organic matter, if it is a nitrogen, if it is a sulfur, then we have to think about chemical process. Particulate matter, only physical process. Please remind this. Particulate matter is a particle, a solid. So we can think about physical process. So particulate adheres to each other, forming agglomerates. So whenever there is a bigger size of particle, it is easy to remove, easy to settle. We know, right? In a self-cleansing mechanism also, particle greater than 20 micron in size that directly settled on its own. So particles when it's adverse cluster will be formed or agglomerates will be formed. Yeah. So first is settling chamber or cyclone collectors. So all are discussed here in a single slide. I think, yep. Everything is discussed here for a stationary source. So, for example, settling chambers and cyclone separators to control industrial dust emissions. As a pre-cleanser, we can use this type of settling chambers because these settling chambers and cyclone collectors are efficient for larger size particles only. So, we can use as a pre-cleansing technology. Wet scrubbers are good for smaller particles. So, to control flammables, explosive dust or mist from sources. And wet scrubbers can also handle hot air streams and sticky particles. Electrostatic precipitators, we can think about power plant having minute particles. Coal power plant or thermal power plant, you will get fine particles emission in the flue gas. So that need to be that can be controlled with the electrostatic precipitator and fabric filters that are all capable of handling fine particulate matters. How to select this particulate collector devices? Based on the particle size, shape, density, based on the particulate loading, how much quantity is there. Bigger quantity of larger size, we can think about gravity settling or cyclone separator. Fine particles with lesser concentration, we can think about electrostatic precipitators or fabric filters, because we can't clean this type of fabric filters often. So that is also important. Efficiency required. If it is only 90% removal is fine, this is fine. Gravity filters is fine. 99.9% removal is required. Think about electrostatic precipitator. Then properties of the carrier gas. If it is hot gas, then we can't go with the fabric filter. It will burn. So that need to be carried. What is the temperature of the gas? What is the pressure? What is the humidity? If it is having a water or moisture, then gravity settler will not work. So that and all need to be taken care. Then flow characteristics, flow rate, variation in the flow rate, specific properties of the contaminant. Maybe the contaminant may be toxic or corrosive, so we can't use the steel chamber, that will get corroded. And allowable pressure drop, because fabric filter and all, it's flowing through a minute pores, so pressure drop, pressure difference plays a major role. Then contaminant disposal after collection, what we are going to do, because if it is a wet scrubber, it will be taken with the water. So what to do with the water, how to treat that water with the pollutant. So contaminant disposal is a major factor. Capital and operating cost, ease of maintenance need to be think about. Okay. Then gaseous criteria pollutant, like we can think three methods. First is for particulate matter. This is for gaseous pollutant like volatile organic compounds. Absorption, adsorption, incineration. These are the three techniques we can use for gaseous pollutants. Okay. So techniques like singly or in combination of adsorption and incineration also we can think about. See here in the coal mines and this type of things are using lots of extraction and utilization. After production, lots of emission is happening that need to be taken care with adsorption and incinerations. So fourth technique is called carbon sequestration. That are all nowadays lots of research are going on carbon sequestration to reduce the carbon footprint. So there is a 13th SDG goal, climate action. That is the main sustainable development goal. Carbon sequestration is coming under that. So whenever the carbon is there in the atmosphere, it will really contribute to the global warming, what we discussed in the last week. So whenever the carbon is sequestrated in the form of solid or contained in a system, then there is no problem with the global warming. So that's automatically reducing the temperature and the impact on the globe. So carbon sequestration is a major research topic nowadays going on. And mobile source, as I mentioned, we can think about three main sources. One is engine exhaust, crankcase, fuel tank, and carburetor. So these are the three emission sources. So means employed to limit the discharge of noxious gas and internal combustion engine and other component. So that's called the emission control system for mobile sources. We have discussed about the stationary source. We have discussed about the area source. Now mobile source. So engine exhaust, if you think about, first is engine exhaust, right? So engine exhaust may be hydrocarbons because it's from the petrol or diesel. So that may be directly converted into hydrocarbon. Nitrates, oxides of nitrogen and sulfates will come. So NOx, SOx will be there. Trace various acids, alcohols, and phenols may happen. You got it? Then crankcase. So crankcase is the housing of the crankshaft, and it is the reciprocating internal combustion engine. You know, right? That those who are from mechanical background, they may know about the crankshaft. These are all the engine components. So it is a secondary source of unburnt hydrocarbon. Those which is burnt, that will come out through the exhaust. Which is unburnt, that will be there as a carbon monoxide. Whenever the carbon is fully oxidized, you will get carbon dioxide. Whenever there is a lack of oxygen, then only CO will be formed. That is called incomplete combustion. If it is a proper oxygen, carbon dioxide will be good. So carbon monoxide is more harmful than carbon dioxide. Then the fuel tank and the carburetor, like again hydrocarbon continuously evaporating from the gasoline constituent. So it's a evaporation because it's a volatile substance. Diesel or a fuel, whatever it's there is a volatile substance. So that will continuously evaporate, form a gasoline constituent. So hydrocarbons will be there as a gaseous form. Then control of emission from the engine exhaust. How to do? Two methods are there. So control emissions which are responsible for two-thirds of the total engine pollutants. So that can be, that is only a major part is exhaust pollution only from the vehicle. So that is a that constitutes around two-thirds. So that can be controlled by two systems. One is exhaust gas recirculation, air injection system. So whatever the gas coming out through the exhaust, that's having good heat, and some maybe NOx, SOx, hydrocarbons will be there, that need to be again sent to the fuel tank, that will be combusted fully and then sent out. So you will get less pollutant out. That is called the exhaust gas recirculation. Then air injection system, air will be injected for proper combustion. So this system, two system we can follow. So exhaust gas recirculation you can see. So there is an engine, there is a production of gas. Then that gas need to be recirculated again for full combustion before emitting into the atmosphere. So specific portion of exhaust gas is directed back to the cylinder head and favors lower production of nitrogen oxides, because if it is fully oxidized, then there won't be much emission. Then air injection system. See here, gas injection, secondary injection of gas will be there. So that will act, that will help for full combustion. So inject air into the exhaust manifold. The air combines with the unburnt hydrocarbon. Whatever is releasing unburnt hydrocarbon, unburnt carbon monoxide. So carbon monoxide at high temperature, and in effect continues the combustion process. CO2 will be released, not CO. You got it? These are the two control mechanism for engine exhaust. See, another area of additional combustion is catalytic converter. So catalytic converter, catalyst are what? Catalyst are the one with substance that will boost the reaction, but it will take part in the reaction without reducing the concentration. So it will go into the reaction, it will come out after the reaction. That's called a catalyst, but it will boost the reaction. So we need more oxygen or more oxidized product in the fuel, means we can use some metal catalysts. So catalytic converter can be used. That's a honeycomb structure coated with a thin layer of metals like platinum or palladium that are all acts as a catalysts. So what it will do? The metals acts as a catalyst and induces the hydrocarbon and carbon monoxide, nitrogen dioxide to convert into water vapor. So it's speeding up the combustion process. With the less amount of oxygen itself, it will speed up with the high. We can't give full heat. We can't give full oxygen. So with that limited purpose itself, catalyst will help to enhance the process. That's the use of catalyst. So metal catalysts can be used. Then crankcase. First one is exhaust, second one is crankcase. So that will be the up and down part in the engine. So from there also some incomplete combustion products will come out. So that can be controlled by proper ventilating air and returned to intake manifold. So we need to add air as well as the recirculation system will make that to combust fully. So the positive crankcase ventilation valve or PCV valves can be used. And from the fuel tank, as I mentioned, fuel tank and carburetor may have some volatile hydrocarbons before going into the engine. This, because we can feel the smell of petrol, right? Every time it will volatile. So that can be controlled by vented directly into the atmosphere. So sealed fuel, earlier it was vented directly into the atmosphere. Nowadays sealed full tank caps and control evaporative control systems will be are attached to all the engines nowadays. Earlier it was directly emitted into the atmosphere. Nowadays we have a proper evaporative control emission systems are in place with the fuel tank and also with the carburetors. So that can be easily controlled, right? So channel fuel vapor through purge valve. So that fuel vapor also purge channelized through the purge valve, and the computer controlled fuel injection system ensures more precise air fuel mixture. So that also will be mixed and used for combustion and lower the generation of pollutants. You got it? So this is about a proper you got the proper idea about control of particulate matter in the stationary source as well as from the moving source and the area source. Also the volatile organic compounds that may be emitted from the moving source, such as moving source, there is a three emission pathways. One is from the exhaust, one is from the carburetor kind of fuel tanks, the third one is from the crankcase. So that devices are the control mechanisms we have discussed. Okay, yeah. So selection of control mechanism is based on the different factors, and natural self-cleansing property is the base for this control system. We have adapted the principles from that natural cleansing properties. Okay, yeah. Now we are going to discuss about particulate matter control or particulate pollutant control devices. Okay, so most effective, this point will come in all the PPTs. We can think most effective method or reduction at the source. So that's what we are doing. So from an industry, we need to have a equipment to remove or to control the pollutant. From indoor, we need to, I mean, not indoor, we can say like any industry or any source, we need to control at the source itself. And particulate matter is the main pollutant, mixture of solid particle and the liquid droplet that can be controlled by uh, different mechanisms. First is gravity settling. These are all mechanism, not the devices. So mechanism behind those devices I am discussing here. So gravity settling. As we know, particle is having higher density or higher mass that will be directly settled by gravity. So this is the basic principle we know, gravity settling. Second one is centrifugal impaction. As you all know, if you are taking a thread with stone, if you are swinging in the hand, the stone will go around. That's due to centrifugal impaction. So whenever there is a weight, that will always try to go around in a circular path. So we are also forcing the air to go in a circular path so that the higher weight particles like particulate matter will be attached to the surface and only the air will go out. You got it? So we are using the mass to remove the pollutant. So mass will have a centrifugal impact. Finally, the third one is direct interception. So you all know whenever there is a barrier and air is flowing through this, air may find a different path to go out. But particulate matter cannot find different path. It will be stick to that barrier. So that is called impaction or interception. So direct interception may happen. Then electrostatic attraction. Whenever the particle is having any charge and the barrier is having a charge, or opposite charge, that will get attracted. So subjected to the electrical field and migrate to one of the surface of the devices, then it will be called electrostatic attraction. Or this control devices and mechanism actually used in India? Is there any recent survey data? All the industries are using this type of devices. I will also show some of the figures maybe in the problem solution. I will show some of the devices how all the nuclear power plants, not only the power plants, all the industries are having proper emission control system in place. You can see nowadays all the industries are having zero liquid discharge, that is mandatory in Tamil Nadu if I say. So they are not releasing any droplet of water out of their industry premises. They are recirculating or recycling the air water for their production. Same air pollution control system is also mandatory. That's why pollution control boards are there. State pollution control board, central pollution control board. They are monitoring. That's what the inventory studies we have discussed. They are collecting data. If there is a excess in concentration, then they will go to they will identify the source and they will cut the industry. So that's the that's how it works. Okay, so actually it's in place in all the industries in India. Maybe some of the micro scale or mini scale industries operating in interior part of SIPCO that may not have this type of facilities, maybe having less fund or manual operating systems. So there we may not find this type of equipments. But major industries should follow. I mean, all industries should follow, but major industries are using this kind of equipments. So those are all the principles behind. I am going to discuss about the equipments also. Hope I answered your question. Yeah. So inertial deposition. So we have discussed about gravity settling, centrifugal impaction, direct interception, and electrostatic attraction is based on the charge and inertial deposition. You all know every particle will have an inertia. Like what we are having in the bus, when we are going in a bus, whenever the bus brake happen, we are moving in a front way. So we are in a system which is moving in a path. Whenever the system stops, all the particle will not stop. Everything have an inertia that will be in motion. So same like particulate matters in the air may have the same inertia. So whenever there is a barrier, the air may go out, but the particles will intercept. Inertially, it will got impact and settle down. Then Brownian motion. Particle will move always in a Brownian motion. This is a school level concept. We all know whenever the particles is in a fluid, that will be in a Brownian movement. So that will cause the particulate matter to attach to the barrier. So we have to have a barrier to remove this type of particulate matter. So these are all the principles or mechanism behind. How to find how much is removed or efficiency? So efficiency will be earlier how much it was. If it is 100 earlier, now it is only 10. Then 100 minus 90, that is 10. That will give you 1 minus 90 by 100. That will give you 10 by 100. Oh, sorry, number of particles of the diameter, gas out. Yeah. So efficiency is 90%. Efficiency is 90%. So you can see here 9 by 100. Yeah. So totally it will be efficiency will be how much removed by total particle that is getting in. So efficiency is 90 percentage. So you can think about how much we have removed from the system, how much particle is getting in. That 1 minus will give you the total efficiency. If it is based on the particle number, the number of particles in by number of gas in, that will give you. One second. Vinod, I am in a live class. I will call you by 8 o'clock. Mm, oh. Okay, so number of particles per meter cube of gas out by number of particles per. This is about total gas. This is about number of particles. That is based on the dia. This is based on total, whatever the dia, total particles. The third one is based on the particle mass. So this much mass of particle of same dia, this much mass of particle of this much dia. So that's whatever the efficiency you want to calculate, you can calculate based on the dia or based on the mass or based on the total. Okay, so type of control system, this three we'll discuss here: settling chambers, inertial separator, cyclone separator. Then next lecture we are going to discuss filters, electrostatic precipitators, scrubbers or wet collectors. Six are major particulate matter control devices. So it's for particulate matters. So settling chamber will work with gravity, inertial separators will work with the inertial principle, cyclones will work with the centrifugal force, filters will be based on physical separation by barriers, and electrostatic precipitator will be based on charge. Scrubbers and wet collectors are based on state change, like water absorption. So particulate matter will get absorbed by the liquid particles. So these are the six principles and six devices. First is settling chamber. So this is a simple type of equipment. So what air is going in with a velocity slower than the velocity, settling velocity. So every particle will have a settling velocity. Those who are from civil background, they may know water. If it is a solid is coming, that will get settled in the tank before leaving. That's called a sedimentation tank or primary settling tank we will call. So in the environment engineering, so water will be going in. So once it is getting, the flow velocity should be less than the settling velocity. So settling velocity will be given by the Stokes law. So Vs will have a formula of settling velocity. So we know the actual flow velocity. So flow velocity should be less than the settling velocity, then the particle will get settled. Why we are having different chambers? Different particle size will have different settling time. Bigger particles will settle first, medium particle will settle later, minute particle will get settled later, I mean further, then pure air will come out with minute particles that cannot be settled, that will come out. Okay, this is a simple principle of gravity based settling. So the principle is settling time, and we are making the flow velocity and the settling velocity same, then before going out it will get settled. You got it? So that's the principle. So velocity is based on what is velocity? Distance by time, that we all know. So what is the flow velocity? This total length is the distance and the time is same. So t. So flow velocity is Vf equal to length by time. And then settling velocity is, this is the h, chamber height is h, because settling velocity is happening vertically. So this is the height need to be traveled. So settling velocity equal to distance traveled is h of the same time. So I am equating this both time. I will get L by Vf equal to h by Vs. And the settling velocity I can find by h into V by L. So this is the settling velocity. You got it. So horizontal flow, this is vertical flow. That is the settling velocity. So settling velocity is Vs equal to Gd square by 18 nu, or 18 mu into density you can keep up. Density of the particle, density of the fluid, that is the air. You got it. So the dia of the particles you can find from this. D is the dia, G is the settling gravity, the acceleration due to gravity 9.81, and mu is the dynamic velocity, viscosity of the fluid. So you can find D from the settling velocity formula. So this is the diameter of the particle that will get settled before the air gets out of the system. You got it? So minimum size of the particle that can be removed in the settling chamber you can find here. If it is flowing in this velocity or settling in this velocity and it is the length of the chamber, then you may know my chamber will remove this particle size, the diameter of the particles. You got it? That's the formula behind. It's a simple formula, Vs formula. If you know, all you can find. That's the settling velocity. You all please study about Stokes law. That's in water. The same can be adapted for air also. Got it? An important aspect is the gas velocity should always be lower than 3 meter per second and to prevent re-entailment of the settled particles. If it is higher than 3 meter per second, then whatever the particle that is get settled due to turbulence, it will again come into the system. So it is main practical aspect. It should be less than 3 meter per second. Less than 0.5 meter per second is very good. So to minimize turbulence, uniform velocity need to be maintained. Pressure drop is need to be adjusted. It should be very small, and the efficiency is improved by height to be traveled by the particle is less. So if, that's why we will call as tube settlers. So particles if it is going through the gas going through the tubes, H will be very lower, and it will get easily settled at the bottom. So that's called a tube settler. Water also we will use nowadays tube settler instead of a tank. We can use tube. So the path will be more. So easily it will get settled. That's what horizontal trays, shells now they are using. The same principle is adapted for air also. 1 to 3 centimeter height intervals. And increasing the efficiency by increasing insertion of horizontal trays. If there is lots of horizontal trays, then air should go through this many distance. Then L will be more. Easily particles will settle here, here, here. Or more pathways we can have to travel. Before that it will settle for sure. Then minimal particle size we can remove is 10 micrometer. What are the application we can use for settling chambers? As you asked, you can see ma'am here. So the remove particle size above 40 micrometer. So wherever you can find 40 micrometer above particle, or else anywhere you can use the settling chamber as a pre-treatment option. We can use first treat the 40 micrometer, then smaller particle we can use some other equipments that will reduce your cost and increase the efficiency. Like remove larger solids from the draft furnace, kilns, cement kilns, or industries like food and metallurgical industries like steel manufacturing, or anywhere you can find this settling chambers. First step is to dust control. All the industries will follow this one. Like dust control is very important. And widely used as a pre-cleanser. As I mentioned, we can use as a pre-treatment option before any other equipments. The advantages: low cost, simple, low maintenance, low pressure drop, dry. There is no need of water here, and easy to construct. Temperature can be not a problem here. Disadvantages: it will take larger space because it's a big equipment, and relatively low particulate matter collection. As I mentioned, only above 20 micrometer can be removed, and the efficiency is only 90% or 80% or 85%. It's a very low efficiency. Okay, then trays in multiple tray settling chambers may wrap during high temperature. So if you are increasing the efficiency by increasing lots of trays, then it will reduce the it will wrap due to high temperature, so it will stick together. So that's the problem here. And inertial separator is the second one. As I mentioned, inertial separator works based on the property of inertia. So relatively greater inertia of the dispersoid to affect the particulate gas separation. You got it? So that is of three type. One is Baffle type separator, Lowry type separator, and dust traps. Principle is greater inertia of the dispersoid is utilized. You can see here. So there is lots of sheets are there. That's called the baffle type, baffle walls or sheets separators. So the flow will be there. That's a series of sudden change in the direction because it's a zigzag sheets. So due to the change in the direction of the gas will go out, but the particles will settle down by inertia. Okay, that's suitable for more than 20 micrometer dia particles. Then slightly more expensive because we need to construct lots of baffles, lots of shapes, and leads to severe abrasion because air will stuck here, so that will cause corrosion of the material. So it's based on number of baffles, length of the baffle, spacing, configuration of the baffles plays a major role here. Then Lorry type separators that will have a sheet of like this. You can see this is a maximized version of this chamber. So you have lots of sheets here. The air will go in, so it will move a different path and it will go out. Before that, the dust will settle and it will be taken out, or dust circuit will say. Okay, here efficiency will be more. Operating velocity is 12 to 15. Larger than 30 micrometer particle can be separated with this type of Lorry traps and dust traps. So gas will come in here and it will move a longer distance to go out, because particles will always settle down, but gas will always move up. Water will flow down, gas will flow up, and solids will go down. So due to gravity, got it? So change direction of 180 degree. Flow is coming and it's taking a U-turn to go out. But particle will not take U-turn. Particle will take straight path and it will settle down. So simple principle of inertia. So dust loading is higher. If it is higher dust loading concentration, we can use this type of dust traps. And power plant rotary cleansers, pre-cleanser, we can use this. Cyclone separators, the second method. First is gravity settlers, second is inertial settlers, third is cyclone separators. So it's working on the principle of centrifugal force. As I mentioned, that whenever there is a mass flowing in a circular path, then the mass will always try to go to the end or the dia of the particles. As I mentioned, a stone tied with the thread, if you turn, that stone will always follow the larger path. Right? Like that, whenever the gas is entering and moving in a circular path, the particles will always tend to go near the surface, and it will always get impact and settle down. The pure gas will go take a U-turn and go out through the top, but particle will not go out through the top, right? So that's the principle. So mass of the particle play a major role, because that's based on centrifugal is based on the, because centrifugal force, if you see, Fc equal to always force equal to mass into acceleration. That's the Newton's second law of principle, right? So force of centrifugal will be mass of the particle, then acceleration will be velocity by time. So Vi by R. R will be your radius of circular cyclone, and V will be the velocity, inertia in inlet gas velocity. The principle is minimum dia of the particle that can be separated is we can find by this. The same we have used for settling velocity in the settling chambers. Here you can use this formula to find the minimum particle size. Then cyclone separator, again here you can see it's a laden gas stream enters tangentially. So it's tangent in the what? Circle. If it is a straight line, then it is called a tangent line. So it's entering into the tangent path, and it will flow a circular cylindrical opening. It will enter, and dust is collected at the bottom of the storage hopper. The gas will go out. So double vortex. Gas path will be double vortex and a spiral downward. Moves upward. So gas will flow upward, but the particle will move downward. Drop by gravity. So 90% efficiency you can find for 10 micrometer particle, 20 micrometer particle, 95% efficiency. So it can be operated at high temperature also. Even for high end atmospheric high pressure also we can use. Gas volume we can handle up to 0.85 to 700 meter cube per minute is the flow rate we can use. Yeah, 15 gas% gas leak can bring down the efficiency to virtually zero. That's the important. So gas leakage should not be there. So that can be measured by this type of graph, particle size and collection efficiency if you find. So particle size is higher, higher efficiency. Yes. So how to increase the efficiency? By dust particle size, inlet loading, cyclone body. So that if it is increases, collection efficiency will also increase. But whenever the gas viscosity cyclone dia increases, the collection efficiency decreases. So these are the factors need to be considered: inlet area, inlet width. So that need to be very small. You can see there are two types: conventional and high efficiency cyclone separators. So particle size greater than 40 will have up to 99% removal efficiency also. So design parameters, like gas inlet, each dimension is matters, like exit diameter, chamber diameter, the dust particle outlet diameter, length of the centrifugal chamber, then collection chamber depth, then inlet depth, inlet height. So everything can be calculated by these formulas that can be adapted. So these are all design aspects. So three important problem is erosion, corrosion, material buildup. So as I mentioned, the particle will stick to the surface, right? Surface of this chamber. So there may be a corrosion, there may be a material buildup that need to be scrapped. So erosion, heavy hard particle, if it hits, it will erode. Corrode, if there is a condensation, because sulfate, if it is there, if it reacts with the moisture, what will happen? SO2 plus H2O, H2SO4 may form. The same will happen with the NO2, HNO3. These are all acids. So that will corrode. Whenever there is a moisture in the air, that's a problem. And then material buildup. Dust cake may form that need to be removed by hanging a chain. But again, it will reduce the efficiency. that are all need to be taken care. Application. Here again it comes the answer for madam's question. Control of gas from cement manufacturing industries, mineral processing, paper and textile industries. They are using this type of cyclonic separators. So we can also use catalytic dust in the petrol industries. So that will also increase the efficiency. So multiple cyclones in series you can see here. Not only one cyclones in series we can adapt, or cyclone in chamber as a whole it will act as a bag, or multiple cyclones. A smaller cyclone operating in parallel. Seen it like this will add up to the efficiency. Like more volume of gas is there, then we can adopt more cyclone chambers in parallel. But cyclones in series, this is required when first one will remove 90%, then 10% will go in. Out of this 90% will be removed in the second. So only one will come out. So 100 will go, 10 will be removed, 90 will be removed, and 10 will go. 9 will be removed and 1 will come out. So this is in series. If you want to increase efficiency, you can follow series. If you want to handle huge amount of air, you can think about parallel. Okay. Yeah. So series, this is efficiency, and parallel, there is a different efficiency. So settling chambers, inertial separators, cyclone separators are the three like used for coarse particles removal. And the third lecture we are going to discuss about fabric filter, electrostatic precipitator, scrubbers. These are all again for particulate matter. All the 6 are for particulate matter only. Again the same principle. So fabric filter, it's simply like a bag, a cloth bag. A cloth bag, whenever the air go in, whenever you are washing your bag, what will you find? Water will come out. It will form a huge bag kind of, right? So particles will settle inside. Only water will come out or air will come out. That's called a fabric filters, having minute pores like a filter paper. So it will filter it. Only the gas will go out. Particles will be settled inside. Or the particle will be, sorry, the air will be sent from outside to inside. Particle will settle outside. Air will go inside. So these two principles we can use. Flow from inside to outside to inside. Two mechanism we can follow, and the back side we can use for cleaning. Okay, the major here you can use up to 0.1 micrometer to 1000 micrometer particle also we can remove with the efficiency of 99%. That's a good thing with the fabric filters. So removal efficiency increases when the pressure drop. But so that's the pressure drop. So whenever there is a pressure drop, it will removal efficiency will increase. So somehow pressure drop owing to the fabric, and drop owing to the caked and adhered particles. So pressure drop will increase whenever the efficiency will get reduced. So there is a two pressure drop. One is due to the fabric, one is due to the cake. Cake is the particles that will be agglomerated on that. So again del PC, you can use this formula to find out. And principle is the air cloth ratio. So that how much, this is a woven fabric only. Woven is, you know, right, weaved like a cloth. How we are stitching the cloth, like that there will be a cloth and there will be pores in between the threads. So that is used to remove the gas out of it. Particles will settle on it on the other side. That's called a cake. So cake will be formed as particles, that is gas. So how much area is available for the air to go out, how much total area of the cloth. So that will be A to C gross ratio. Q maximum by A total you can find to find the A by C ratio. The net also you can find by the net area. So the principle is impaction. So whenever the particle is coming with the fabric, it will get impacted. Or Brownian moment, whenever the particle is moving in a zigzag, it will get impacted. Or based on the fabric may have a negative charge that may get absorbed. So 99% efficiency. But particle size plays a major role. Out from 1 to 1000 micrometer particles, it is effective. 0.1 to 1, there is a drop in the efficiency. Only 75% efficiency is there. That's the problem. And cleaning is again a major issue. Whatever the cake formed on the other side of the fabrics, that can be wrapped, shaked, vibrated to remove. Wrapping is by a wrapper, we can wrap it. And normal velocity of the airflow through bags is 0.4 to 1 meter per minute. That's the flow rate. And efficiency of the bag may increase by excessive filter ratio and improve selection of filter media. What is the material you are going to use for that? So improper selection of filter media reduces efficiency, and cleaning is another operating parameter. As I mentioned, rupture of the fabric. Whenever there is acidic gas or a moisture is there in the inlet gas, that will rupture the fabric. And temperature, it should be allowed only with less temperature, because the fabric may get fired. Bleeding is the dust may come out along with the effluent gas. So that's called bleeding. Whenever the fabric get thick or there is a hole in the fabric, then dust particle may come out. That's the problem. Humidity, moisture is the hygroscopic, fabric will become hygroscopic, and chemical attack, possibility of chemical attack like sulfur dioxide and nitrous oxide, that is again a problem. So filter media will be selected based on the area gas temperature, composition, gas flow rate, and size and shape of the particles. Based on that, we can wove the fabrics. So how much size it need to be given to go out. So these are the different fabrics we can take: cotton, wool, nylon, and polypropylene. Plastics also we can use fiberglass as a material, because fiberglass can have a less pore size. It will be like this fiberglasses. So we'll find minute pores, but it will not get ruptured. It will have a good strength and property. So based on acid resistance, alkali resistance, flux, abrasion resistance, and tensile strength. Strength also plays a major role, because high pressure need to be taken care. So fiberglass, if you see, it's having good and fair acid attack. It is having good strength. See, 14,000 is the strength. Strength is good for the glass fiber. We are using for concrete also, this glass fibers. But acid attack is very less efficiency. But if you think about polypropylene as a plastic, acid attack will be good. But even it is excellent for flux ratio also. But plastic will not handle higher temperature. For that, Dacron can be used for handling higher temperature. So, what is your industry's thing? You can think about which fabric you can take for fabric filters. Okay, then envelope type fabric filters, uh, multi-compartment type bag house. It's same like parallel cyclone separators. Like you can add fabric filters in a series or in a row. So there will be a huge compartment. Each bags will be hanged. You can see here. So this is a compartment with the different bags. So this whole thing is called a bag house. So 9 bags. Each bag will have different filters. So each filter will have different components. You can think it's a million of components in a single compartment. That's called a bag house. So it will have a huge efficiency, 99% removal. So the application will be for all metal engineers, foundry, cement, wherever the particulate matter is coming out, we can use this type of fabric filter. But we can use, so gravity settler as a pre-cleanser, then we can use this type of fabric filters. Okay, so that's a good efficiency is the major thing for smaller particles and dry collection and disposal. But the problem is operating limit. So we need a proper pre-treatment. It requires a dry environment. Then electrostatic precipitators. So electrostatic precipitators works on the principle of electrostatic attraction. So this I will explain in a smaller graph. So there are plates. So the plates are getting charged by positive charges. So the plates are given with the positive charges. Okay. And there is a steel rod or any rod at the center that will discharge negative charge. Negative charge is getting discharged. So I'm seeing the side view. So the air is going through this way. Okay. Each side wave path I am saying. So air is going through this way. Whenever the air is pure, it will not get charged. Whenever the air is having particulate matter, then the particulate matter will absorb this corona discharge. This is called a corona discharge. Whenever there is a negative charge, surplus of negative charge is getting discharged, that's called a corona discharge. So that will be attracted by the particulate matter, and the particulate matter will get this negative charge. Once the particulate matter is getting negative charge, the plates are already having positive charge, so it will get attracted toward that. So the particulate matter will get here and it will get deposited. You got it? Whenever there is no charge, the particles will get deposited at the bottom. So this is the principle of electrostatic precipitators. So it's getting precipitated. That's why it's called a precipitator. There is no water here, but it is getting concentrated. That's why it's called electrostatic precipitators. So there is an electrode to supply positive charge to the plates and negative charge to the thin metal rods, and the air with the particle matters are going in. Pure air will not get any charge, that will go out. Only the particulate matter will get this negative charge and attracted to the positive charge in the plates, and it will get settled down. You got it? So that's the principle here. Here you can remove 10 to 20 micrometer size particle using electrical energy to trade. But here electrical energy is required. So drift velocity is the major parameter here. Can calculate using this formula. And the efficiency can be calculated with the efficiency equal to 1 minus e power minus drift velocity area of the plates by your volume of flow rate. So A will be available collection area. That's the plate area, sides I'm talking about. So the whole thing will be charged with the positives, right? So this equation is called Dash Anderson equation. And the modified version is the same. You can use with the I. That's the drift velocity with ith particle height. And the overall efficiency can be calculated with this equation. That's 1 minus e power minus wi. It's omega actually. Again, here is the problem is 0.1 to 10 micrometer particle. About 10 micrometer, it's very easy to remove, having 100% efficiency. But very high efficiency above 1 micrometer particle. Increased efficient charging causes collection efficiency to increase from particle. But there is a difficult to control 1.1 to 1 micrometer uh, of both of this charging mechanism. That's called the corona power. How much power required? Because we need to give to the electrode and also to the rods, right? So how much corona power and pressure drop, that can be calculated. Power can be calculated with this equation. How much current into voltage, that will give you the power. So corona current and average power. So here you can see 98.5% is effective collection efficiency we can get with the different corona power ratio. So different potential, high potential difference will cause higher collection efficiency. Yeah. So there are two principles here. One is dry ESP, another one is wet ESP. So how to collect the particle that is get attracted to the plates? Whenever there is no charge, then the particles settled on the plates can be removed dry or can be washed. So that two principles are called dry ESP, wet ESP. Whatever we are using or not, it's based on that. We can classify as dry ESP and wet ESP. So here collection efficiency is 99%. That's a good efficiency here. So the parameter affects volumetric flow rate, composition, temperature, and dew point. Dew point is the point at which the gas will convert into a droplet or a liquid. So that is major thing, because whenever the sulfate dioxide is there, whenever the temperature is very low, then it will be converted into liquid thing. So that will form acid. So relating to dust particles, concentration, size, distribution, that all matters. Okay, again here it is single stage and two stage, that will you can read like pipe, like, so if it is a honeycomb like structure, the whole will be acting as electrode, and the center part you can see the corona discharge. This is plate type, this is pipe type. So gas will flow through this, rods will discharge the negative charge, and the whole surface will be with the positive charge. Same, it will react with the plates, parallel plates. So here all the industries again it will use this type of things. So whenever there is a particle with the acid mist along with the water droplets, this can be very useful, electrostatic precipitators. Or you can say this as a ionizer. Ionizer is the other name for electrostatic precipitator, ionizer. Okay. I think this question is asked in today's uh, assignment. Yeah. So advantage is high efficiency. Particles smaller than 0.1 can also be removed. Higher initial cost, because there is a cost required for electrical discharge, and poisonous gas and ozone may be produced due to ionization, because charge may produce any compound in the air. That is another problem. Possible explosion may also happen. Then wet scrubber. Wet scrubbers are the one which uses water to remove the particulate matters. So you all know after rain you will get good visibility. Why? Because whatever the dust in the air, it is removed by the rain droplets. That's why we can see a clear vision after rain. The same principle we can adapt for wet scrubbers. Water we are spraying above the gas, that will collect all the particles in the gas, and it will settle down, because water is flowing from top to bottom. Gas is flowing from bottom to top. So gas will come out, water will come out with the particles. So wastewater we have to treat. That's the only problem here. We will generate wastewater with the particles. That can be easily settled. Again, the same principle of Stokes law. So greater high inertial force. Again, the principle is inertia only. The particle should go into the water molecule. That's the inertia only. Whenever there is a contact, then only it will get absorbed. Absorption principle only. So Brownian moment, inertial impaction, electrostatic, because particle droplet may have energy, and porosis. Again, the droplet may be having a particle size that will get attracted. These are the five mechanisms behind the absorption principle. Yeah. So there are different types of wet scrubbers: spray towers, venturi scrubbers, cyclone scrubbers, packed scrubbers, mechanical scrubbers. Scrubber in the sense using water to remove the particles. You can see here spray towers. There are a lot of showers. You know shower, right? So like that, water will be sprayed. So gas with dust particles is coming. and it is clean air is going out, particle is getting absorbed into the water molecule and getting down as a wastewater collected. So even 5 micrometer in dia particles are also effectively removed. So this is the overall efficiency we can find from the this equation, and so the major part is terminal velocity here, Vt, and spray tower efficiency can be calculated by impaction number and impaction collection efficiency, because it's worked on the principle of impaction. And Venturi scrubber, so it's in the shape of this. So here is the throat velocity plays a major role, and the principal collection mechanism inertial impact again. Okay, then the Venturi scrubber efficiency can calculate with this formula. Cyclone separator, again spraying will happen same like scrubber, but the gas will flow in a circular path. That's why it's called a cyclone scrubbers. Then packed scrubbers, again water is spraying from the top, gas is going in, but there is some packing material to absorb some. So you will get easily higher efficiency here. And the packed scrubber, you can see the above the bed there is a trickling, same like shower. And then mechanical scrubbers. Mechanical scrubber uses, you can see, accelerate the gas stream to create condition favorable for the particle impaction. Above and all, there is no automation for making the particle to contact with these droplets. But here we are making the condition favorable for the particles to impact with the water droplets. So the fan type mechanical aided scrubbers are used to take out these particles. So even 1 micrometer particle can also be effectively removed. Yeah. So here main advantage is, along with the particulate matter, what are the other gaseous pollutants like sulfates, nitrates, and even volatile organic compound can also be mixed with the water, and that can be removed along with the wastewater. So that's the advantage with other particulate matter control equipment with the wet scrubbers. Okay. So but the disadvantage is effluent liquid. What can we do with the wastewater? We need a wastewater treatment plant. So we are just converting the pollutant type from air to water. We have converted. They didn't remove. So that's the problem here. The waste product collected with high potential for corrosion problem. That is all is the problem, because water is there, easily sulfur dioxide, sulfuric acid, nitric acid will form. Yeah. Then we are going to discuss about the gaseous pollutant control equipment. As of now, we have discussed about the particulate matter control equipment. Now, gaseous pollutant control equipment. I'll finish in 10 minutes here. So we'll discuss the old assignment later. So I thought this will be very useful. This is a major part of our course. So I am taking more time in this air pollution control equipments. Okay. So as of now, we have seen about the particulate matter control equipments. One is gravity settler. Second one is impact settlers. Third one is cyclone separator. Fourth one is electrostatic precipitator. Fifth one is what we see now, filter bags. The sixth one is the last one, wet scrubbers. So six devices used for controlling the particulate matter. Now the gaseous pollutant like volatile organic compounds, NO2, SO2, that can be removed by three major principles: adsorption, absorption, biofiltration. Okay, and also we can use oxidation and condensation as a chemical treatment methods. So adsorption is a interaction between the gaseous molecule and a solid absorbent. So adsorption will happen only on the surface. So this, again there is a two PM particulate matter was removed only with the physical methods. So these are all based on chemical methods. There are physical adsorption and chemical adsorption may also happen. So physical adsorption is due to weak van der Waals force of intermolecular cohesion, that can be removed easily. But chemical adsorption is due to proper chemical bond between these two particles, solid and the gas particles. So this will be not irreversible. So adsorbent, we can use any activated carbon, zeolite, synthetic polymers. So activated carbon is a major adsorbent. So nowadays cosmetics are all coming with this type of activated carbon for face wash and all. That will remove, that is having, the major point is surface area here. Whenever the particle is having good surface area, I mean lots of pore means more surface area. So more surface area again impacts more pore are there, that will take all the pollutant. So you are using this as a face wash, so lots of pollutant in your face that will get absorbed onto this type of activated carbon. Activated charcoal face wash are there. So zeolite, synthetic polymers, silica gel, activated alumina, these are all adsorbent, having higher pore surface area. You can see here surface area major role. So synthetic polymers are having nowadays higher surface area, but if you think about mean pore diameter, that is again play a major role in flow. So it should be also more mean pore diameter. So you can think about which adsorbent you can use for which industry based on your gas characteristics. Then non-regenerative adsorption system is based on chemical methods. So that after treatment or after air treatment, you can take the adsorbent and you can discard. That is called non-regenerative. This is used for water control, low contaminant concentration. You can use it. But regenerative adsorption mechanisms, whatever the package material adsorbent, we can reuse again and again. So for large scale application, we can use this type of things. So how the system works: fixed bed, moving bed, and fluidized bed we can use. So how the absorption is happening? First, the contaminant is coming and getting contact with the surface of the adsorbent. Then it is moving through the pores. That is migration. Then monolayer buildup is forming at the top. Again, multilayer. These are all based on isotherms. Fruitlich, Langmuir. Langmuir work with monolayer adsorption. Fruitlich and Bett works with the multilayer adsorptions. Okay. Then adsorption forces may be physical and chemical. We have already discussed. That is called physisorption and chemisorption. Then adsorption principles, we have three equilibrium condition. Equilibrium is whenever the pore size are fully filled, that is called the equilibrium condition. That can be measured with isotherms, isobars, and isostir. Okay, isotherms is a plot between partial pressure and capacity weight. So that gives you the isotherm. That's a, all of these are a plots only. So for a constant temperature, adsorption capacity increases as the partial pressure increases. That's what the result from this graph. Okay, and isobars are the plot between temperature and amount of vapor absorbed. So this is all for vapor pollutant. So you can see here for a constant temperature, whenever the amount of adsorption decreases with the increase in the temperature. For constant pressure, for constant temperature, how the pressure works. For constant pressure, how the temperature works. These are all based on isotherm, isobars. For then isostir. Isostir is the graph between natural log of pressure, that is ln P, versus 1 by T or 1 by T in the x-axis. Ln P will be in your y-axis. You can see 0.1, 10, 100, 1000 is a long scale. So the slope of this isostir will give you the differential heat of adsorption. If it is more, then more of material will get adsorbed. So these three are the indicators to measure the equilibrium or the efficiency in adsorption. Then operating parameter will be your bed depth. Again, here comes the mass transfer zone, MTS, depends on 6 separate factors. So that's the minimum depth required for adsorption. You can't fill 1 mm adsorbent. You have to fill 10 centimeter adsorption. Or how to fix the depth? That's based on mass transfer zone. Okay, so the bed depth concept. Then summary will you will give that acid, gas, and organic compound can be used for a range of less than 1 ppm also, 130 Fahrenheit also we can use this. Yeah. Then absorption. Absorption. Absorption is transfer of gaseous component into liquid phase. Earlier it was adsorption. Gaseous particle, the particulate gases will be adsorbed onto the surface of the solid. Here it will be on the liquid phase. Okay, that's the mass transfer. The time available for the diffusion all plays a major role. Then different types of absorber will be spray towers, packed bed towers, tray towers, venturi and ejector absorbers will be there. So the mechanism here is it is coming and contacting with the liquid surface and it will be entering into the bulk liquid. Earlier it was gas. Gas it will be there when the liquid phase will be there. It is transferring from the gas phase to the liquid phase. That's the interface. It's getting transferred. Then it is entering into the bulk liquid. That's the mechanism. So it's based on the Henry's law principle. So again you can see contaminant reactions, absorbing sizing and absorber sizing, everything plays a major role here. And the alkali requirement. Why we need an alkali here? Because there is a usually calculated based on the quantity of acid gas captured. So we need to add external alkali to neutralize the water what we are using. So water is required for absorption, right? Or any moisture or any liquid is required. For in the liquid, acid will get created whenever there is a sulfur dioxide at all. So we need to add alkali. So how much acid is produced to neutralize that? We need to calculate the alkali requirement. Yeah. Then finally, biofiltration. Biofiltration helps to remove the gaseous air pollutant by microorganism oxidation. So the contaminant is metabolized by the organism. Metabolized means it will take up into its body structure and it will release minor toxic elements like carbon dioxide and water vapor. And it's the irreversible process. So biofiltration, we can after absorption into thin water layers, we can use microorganisms to metabolize the dissolved organic compounds. So organic compounds are the food for microorganism, and it is measured by grams of pollutant per unit volume per hour. Yeah. So you can use empty bed residence time or true bed residence time as operating conditions here. Yeah. So finally, again for gaseous pollutant, after absorption and biofiltration, you can also think about condensation and oxidation here. Yeah. So volatile organic compound can is a carbon and hydrogen, right? Whenever you are giving oxygen, it will be easily converted into CO2 and H2O. That is a less toxic. So all the volatile organic compound can be oxidized or condensed because this may have some value. So this will be frozen out and we will take as a product, value added product. That's condensation. For giving oxidation at high temperature, we can get this less toxic pollutant. So that is a oxidation. So these two are the principles. So all chemical oxidation systems destroys organic compound in the effluent gas system. It's the economic recovery of the compound is impractical. We can think about incinerating it. So destroy a wide range of organic pollutants at high temperature, gas-based oxidation system or a catalytic oxidation system. We can use the same what we used in the exhaust engine. The same catalytic oxidation system we can use here. So we have four major categories: recuperative thermal oxidazers, regenerative thermal oxidazers, boilers, and flares. So all four of these process types use very high gas temperature and convert combustible material to combustible material is hydrocarbons. So that will be converted to carbon dioxide, water at very high temperature and combustion products. Pyrolysis also we can think about here. So at 1000 degree Fahrenheit to 2000 degree Fahrenheit we can use this. It's around 550 to 1000 degrees Celsius. So both thermal oxidazers and catalytic oxidazers used to treat or oxidize the effluent gas. So flares are used primarily to treat emergency vent gases, like emergency vent gases in the sense whatever the excess chemicals that is coming out in the emergency that can be used. Flares can be used to treat those. So here recuperative thermal oxidazers, it's a tubular and a plate exchanger. So here you can see it will give high energy to combust the volatile organic compound. So pass on one side of the tube bud tank and the cold inlet gas will pass through the other. That will collect the heat that is produced. Because hydrocarbons when it's burned, it produces heat that can be trapped with again can be used for energy generation that can be placed again into the same system. So in regenerative thermal oxidazers, so a generator is a set of refractory packed bed. There, the heat recovery can be 95% because we are recovering the heat. Here, there is no recovery of heat. Here, we can recover the heat. Yeah. So there is a three compartment. One is the preheat system and transfer of heat to the combustion. Same like what we say like thermal power plants. And then finally, is purge cycle. Boilers. Boilers are the alternative to install a thermal oxidizer is to burn the waste stream in an existing plant or a process boilers. And finally, flares, as I mentioned, flares are only used for emergency emission disposals. Okay. So factors here are flue gas flow rate, combustion chamber volume, catalytic. Finally, it's catalytic oxidation system. That which catalyst we are using for the same can be oxidized with lower temperature and lower oxygen rate. So we can use some catalytic material like metallic catalyst like palladium, platinum we can use. So that accelerates the chemical reaction without changing itself. So that's the catalyst. So waste gas is passed through a layer of catalyst at even very low temperature because there we have think about 500 to 1000 degree. Here we can do this in 300 degrees Celsius itself by using a catalyst. Same efficiency we can get. So can achieve organic compound efficiency, destruction efficiency of 95%. So think about the catalytic conversion technologies. So here the efficiency, I mean the flow can be calculated by QE, QF and QD. That is emission stream, natural gas, and also what we are the fuel what we are giving a dilution air. Okay. Yeah. So this is the oxidation principle. Whatever the hydrocarbon when it is there, it will give you oxidized and it will give you CO2 and H2O. Whenever the N is there, that will come out as N2O or N2. If it is fully oxidized, S is there, this will come out SO2. So that's the principle, simple principle, general reaction. Okay, so that's based on gas temperature, combustible material, sufficient air, and residence time. Yeah. So this is a kinetic behind that. So how much mass transfer that's happening. So that's based on the catalytic oxidation system. Final one is condenser. Condensation will oxidation will oxidize all the hydrocarbon into CO2 and H2O. But whenever I want this organic matter to recover, why we need to waste the hydrocarbons just to burn and get out? I need this. I can collect this hydrocarbon and I can use this as a valuable product, right? So how to collect this? We can use condensation principle. Whenever a pollutant recovery is required at a moderate to high concentration, then we can think about condensation. The three major categories. One is conventional refrigeration condensers and cryogenic condensers are there. So that are all freezing out at lower temperature like 5 to 25 degrees Celsius, minus 45 to 100 degrees Celsius, minus 75 to 200 degrees Celsius, minus 200 I'm saying. So that will freeze out this organic pollutant and only the gas will get escaped and organic pollutant will be trapped or can be collected and stored and used for further utilization purposes. So simple and relatively inexpensive, only uses a very low temperature. And two basic system are direct contact condenser and surface condensers. You can see here, it's like again spraying of cool water or a coolant, same like wet scrubber, spray towers that will spray the coolant, will get absorbed, condensed to the volatile organic matters. Then surface condensers, we are actually making the gas to flow through the tubes, and from the external, the tubes are cooled. So inside the tubes, it will get what do you say? The condenser liquid will be taken out here from the tubes. Then refrigeration system, we are refrigerating the whole gas, and this heat vaporizes the coolant liquid and compressed to form a vapor stream at high pressure and temperature. Then cryogenic system that uses a liquefied gas like nitrogen or carbon dioxide to cool the wastewater stream, because nitrogen when it is in a liquid form it will be at a very low temperature. It's a liquid nitrogen or liquid carbon dioxide you can use to freezing point of the solvents. So that lower volatile organic concentration, if it is there, we can use this type of cryogenic systems. So there are again three types: indirect contact, single, indirect contact, dual, and direct contact. So based on the again contact mechanism and to increase the efficiency. The major factor here is condenser heat load. Yes. And a coolant flow rate. These two are major operating parameters here. So whenever we need to think about the volatile organic compounds are non-economical, then we can easily flare it. That's the oxidation technique. If you want to recover the material, we can think about condensation. So that's again refrigerant and the cryogenic condensation systems are also having higher efficiency. So you got it. So I will summarize this. So we have discussed today about the air pollution control devices. So for that first lecture we have discussed about the principles. The basic principles are taken from the natural self-cleansing mechanism of the air. It's based on the nature. That was adapted and we made some devices. So for different sources like moving, stationary source and also area source, we have discussed different mechanisms. And the particulate matter, we have designed 6 devices. One is the gravity settlers, cyclone separators, inertial separators, fabric filters, electrostatic precipitators, and finally wet scrubbers. For volatile organic compounds, we have any gaseous pollutant. We thought of using absorption, adsorption, biofiltration. Here, oxidation and condensation. These 5 are the major techniques we can use to remove the gaseous pollutants. Okay. So if you have any doubt, please post it in the chat box, or you can unmute and you can ask. Otherwise, we'll move on to the problem solving session. Okay, you can post the questions in between the session also. I'll ready to answer. Or you can also unmute and you can ask. I will read the question. You please post the answers in the chat box. Yeah. So first question is, gasoline fumes evaporating from the fuel tank and carburetor are vented directly into the atmosphere. This emission are significantly reduced by. So from the moving source, I'll take the pen once. Yeah. So moving source, like a car, if you see a car. So there are 3 emission sources are there. One is from the exhaust. So there is a pollutant coming out. One is from the fuel tank and the carburetor. the evaporated gas may come out. The other one is from the uh, canister, or what is it? What is it? The crank case. So that will emit some unoxidized or incombusted matters. So emission from the exhaust, emission from the crankcase, emission from the tank. So emission from the tank was earlier, it was directly entered into the atmosphere, but now we have a mechanism. What is that? Air injection system, catalytic converter, positive crank ventilation system, evaporative control system. Sorry sir, the answer is not A, because it's fuel tank. Evaporation is happening. How to control that? So answer is actually D. Evaporative control system we have to use. I'll show the picture, then you may understand. So it's from the fuel tank and the carburetor we are talking about. There are three sources. One is from the exhaust, one is from the crankcase, that will be uncombusted air. This is the combusted air. Third one is fuel tank. That is simply the evaporation. So we have to control the evaporation. That's the evaporation control system. So you can see here. In the past, the fuel tank, whatever the gas fumes, that is directly vented into atmosphere. But today we are having a sealed fuel tank caps and evaporative control system. Evaporative emission system is there. Emission control system is there. Okay, that's the answer. Yeah. Please check your answer, sir. We will move on to the second question. So here I have given the control devices and the self-cleansing properties. So please match the device with its mechanism. Okay, the first one is use of activated carbon. Second one is cyclone scrubber. Third one is spray towers. Fourth one is settling chamber. The principles are absorption, adsorption, gravity settling, inertial settling. So what is for activated carbon? Activated carbon is a good adsorbent. Okay. Then cyclone scrubber. So that's based on cyclone scrubber will be a circular motion, a centrifugal force. So it will be inertial force, it will be attracted to the surface. So cyclone separator is based on inertia. Spray towers. Spray towers uses water. Water will be, gaseous pollutant will be absorbed. AB, absorbed. Settling chambers. Settling chamber is a simple principle of gravity settling. You got it? So what's the answer? P will be 3. Okay. Q will be scrubber 4. So this is the answer. Right? Answer C is right. P is 3, Q is 4. Spray towers, absorption, settling chamber, gravitation. It's correct. So option C is correct. Yeah. You can see settling chamber is based on gravity. Cyclone separator is based on centrifugal force of inertia. Spray towers is based on water absorption, scrubbing, liquid absorption. Activated carbon is based on adsorbent. Okay. Yes. So the third question, please post the answer in the chat box. In which of the following pollutants removal mechanism the gas is allowed to flow a circular path which cause the particle to impact on the outer periphery of the device? So we are entering in a tangential motion and it is getting circular path, and the pollutant is getting inertially impacted on the periphery of the device. So there is a tank on the periphery of the device, it is getting impacted and removed. What this is called? The gravity settling, centrifugal impaction, electrostatic attraction, and Brownian diffusion. They are asking about the mechanism. Also, you can say the device name. So the principle is, what is the principle? Circular motion itself, what is called? Centrifugal impaction. So option is B. What is the device is called? Option B is correct. What is the device? Cyclone separator. Right? It's a cyclone separator, uses a centrifugal force that drives the particle suspended onto the wall. Yeah, option B is correct. Yes, sir, correct. Okay. The fourth question. Choose the correct statement related to the settling chamber. They are asking about the settling chamber. So this is again the relation between relation based on the Stokes law. As I mentioned, the settling velocity and the flow velocity. They are asking solids move along the chamber with a stroke velocity and settle with the velocity of the gas. So that's what they have asked. So I am drawing the chamber. It's a settling chamber having different settling compartments. So whatever the flow, solids will entering in the flow, that is flow velocity along the chamber, and across the chamber, that is vertically settling velocity. So which should be greater? Vf should be less than the settling velocity, because settling velocity should be greater, then only it will settle. Solids move along the chamber with the flow velocity and settle with the Stokes velocity, right? So which option is correct? Solids move along the chamber with the velocity of gas and settle with the Stokes velocity. Option B is correct. Yeah. Solid move along the chamber with the velocity of the gas and settle with the Stokes velocity. Yes. Option B is correct. Here you can see. Settling time is same. That's why we have solids move along the chamber with the velocity of the gas and settles with the Stokes velocity. This is V, this is Vs. Yes. So the fifth question, in which of the following control devices fluid gas is passed through a tightly woven or filtered fabric? It's a fabric, causing particulates in a flue gas to be collected on a fabric by sieving and other mechanism. So again sieving only, like it's a fabric means it will be like what? Woven. So within this pores, the particle is getting released. Sorry, the gas is getting released, particle is getting absorbed, filtered. So it's called a fabric filter. So this mechanism is called filtration. So because of the size, because of the impaction, it's getting filtered out. That's called filters. So tightly woven fabrics are used, or any material you can use, polypropylene or a glass fiber. Different materials you can use, but not only the woven fabrics. That's the mechanism of filters. B, filter bags. Yeah, correct. So they are asking for the mechanism, so it's a filter. If it's a device, then it's called a filter bag or a filter house or back house. Yes, correct. So it's a tightly woven or filtered fabric by sieving and other mechanisms. It's a sieving mechanism only, right? If we are using, some days they will use like cloth for sieving the lime and all. So it's a sieving only. We are using normal sieves for atta and all. The same we can use cloth as a sieve, right? So that's what the principle here. Yeah. So, which is a modified Dewey-Anderson equation used in the electrostatic precipitator. So, efficiency is eta equal to, what is efficiency here? Eta equal to 1 minus e power minus omega. Omega is the drift velocity A by Q. So, modified is eta I omega I. So, omega I, eta I equal to 1 minus e power minus omega I C A by Q. So, this is the efficiency equation for electrostatic precipitator connecting the drift velocity, particle size, collection area and volumetric flow rate. So, this is the drift velocity, velocity is omega or V. A is the available collection area in the electrostatic collection area is there is a plate, right? So, this is the whole collection area. If it is a tube type, so whole tube is the collection area. That's why if we increase the collection area, we'll get more efficiency. That's why they change it from plate to tube. And Q is the volumetric flow rate. So C is correct. So ESP, that's electrostatic precipitator. So efficiency is eta equal to 1 minus e power minus. So if it is a modified equation, I, the ith particle. Okay. So seventh question. Which of the following? Yeah. Ma'am, you have raised a question. Okay. It's wrongly. Okay. So there are they are asking which defines the plot of natural log of pressure versus reciprocal of the absolute temperature for at a constant amount of vapor absorbed and establishing the adsorption capacity relation. So for establishing the adsorption capacity or equilibrium, we have three definitions. One is isotherm, second one is isobar, third one is isostir. So isotherm is the one at a constant pressure. What is the efficiency or a collection at a different temperatures? So whenever the temperature increases, the adsorption increases. That's what the graph says. Isobar is the one at a constant temperature. If the pressure changes, what will be the happen? So pressure, it will get decreased. The absorption will get decreased whenever the pressure increases. But isosphere is the one which gives the graph between 1 by temperature, that's the reciprocal of the temperature, sorry, ln of pressure with the 1 by temperature. So that is called isosphere. So that will give you a proper temperature or a capacity at which the adsorbent is getting equilibrium. So the question is asked between the plot between all are plots, all the three are plots only. So they are asking about the plot between ln of first pressure is 1 by T, reciprocal of the absolute temperature. It's called isosphere. So this is isotherm. Isotherm is partial pressure is at constant pressure, how the temperature varies. At same at constant pressure, what will be the temperature variation? Third one is isosphere, that shows the 1 by pressure versus 1 by T. 1 by T. Okay. So okay. So answer is isosphere for that. Then eighth question. The type of force involved in physical adsorption. Type of force involved in physical adsorption, which are electrostatic in nature. So physical adsorption, what will be? There are two types of adsorption. One is physical, one is chemical. So physical adsorption, what is the force involved? Weak van der Waals force. For chemical adsorption, will be the chemical force. A covalent bond will be formed. So here physical adsorption, electrostatic in nature, that will be based on van der Waals weak force. So again electrostatic force only, it's a weak force. Because it's, you know, right, this type of electrostatic force. Whenever you rub paper on your head and you try to take another paper, scale on your head, and if you try to take a paper, that's the electrostatic force. It will not last for a long time, right? So it's a weak van der Waals force. But if it is a chemical reaction, a covalent bond, then it will be always irreversible. So here they are asking about physical adsorption, that's the van der Waals force. Yeah. Physical is due to weaker van der Waals intermolecular cohesion. So ninth question is, which of the following processes of high temperature gas phase oxidation is used primarily to treat emergency vent gases? So we have four oxidation mechanism which is used to treat emergency vent gases. Recuperative thermal oxidizers, regenerative thermal oxidizers, boilers, flares. We have seen in a gas phase oxidation, emergency vent out can be treated by flares. Yes, flares, right? Flares are used to oil and chemical chambers to dispose or of intermittent or emergency emissions. Yeah, option D is correct. Yes, correct. So last question, 10th question. Which of the following technique is adopted when the contaminant concentration is high enough to make a recovery feasible or economical? So, whenever a gas, volatile organic compound, or any gas is pollutant, can be removed by 5 methods: absorption, adsorption, AB, AD, biofiltration, condensation, sorry, oxidation, and condensation. Whenever there is a high concentration of volatile organic compounds are there, I don't want to waste, but I want to recover feasible and it should be economical. Which method I will go for? Biofiltration, isotherm, condensation, and absorption. So condensation will give you the recovered product. So option C is correct because it will freeze out. It will give you the product that can be taken out instead of simply oxidizing and flaring to convert into CO2. There is no use. If it is less concentration, we can do that. If it is high concentration, we can try for recovering and reuse, right? So option C, condensation is correct. Okay. So condensation is exclusively used for recovery of organic compound when they are present in moderate to high concentration in industrial effluent gas. So we can use three types. One is conventional, having lesser temperature. Refrigerant, having more lesser temperature, minus 45 to 100. Cryogenic will use minus 75 to minus 195. So that's it about today. We have discussed the major portion of this air pollution control subject, like air pollution control devices for particulate matter and organic gases. So hope you have enjoyed the session. Don't forget to write your assignment before Wednesday. So ninth week assignment is open. Deadline is tomorrow, and the next session is next Tuesday, 6 to 8 p.m. Thanks for joining. If you have any doubt, please unmute and you can ask or you can post in the chat box. I'll be here for next 5 minutes. Others who are not having any doubt, you can leave the meet. Thank you so much for joining. We'll meet next week, Tuesday 6 to 8 in the 10th week session. Thank you all. Thank you. Thank you so much for joining. So if you have don't no questions, I will end the meet. I'm closing the meet. Thank you so much for joining.